Okay. Hello world. This is day 130. I think the number is correct. Let me check. It is day 130. Of studying compilers every day until I land a compiler role. Last time we did a little bit of cleanup work with some of the stuff leading up to regalloc. And I think all of that's pretty much resolved now. We got that merged. This time, I'm quite tired, so I'm probably not going to do a whole lot. But I'm going to at least start thinking about generating the interference graph for regalloc. We have liveness analysis, so we just need to figure out which variables are. I guess we just need to figure out which registers we have problems with, and then we can split live ranges, spill some registers, figure out what to do from there. Yeah, it should be a pretty good time. This is definitely, I think, the most difficult thing I need to work on. So, yeah, or I guess regalloc as a whole is the hardest thing. Everything else is I think a little bit less annoying, but yeah. What's good, Niraj and Epic? Good to see y'all. 7:40 a.m. here, damn. Yeah, y'all are up early. I could never get up before 10. I feel like. Yeah. Anyway. So again, I guess where are we here? Let's make a branch. What do we want to call it? I guess interference, I think. Yeah. Okay. What am I looking for? Let's look at the Muchnick book again. This is all under the regalloc chapter, so I think there should be some sort of an explanation. Unless maybe what if we look for someone's slides online? Stanford slides, okay. Sure. Okay, nice. Yeah, this looks about right for where we are. Trying out Visual Studio 2026. Any thoughts? I don't know, I haven't tried it. I do not think I could give any thoughts. Okay, are any of these slides gonna be usable? Possibly. Okay. Sure. I guess that makes sense. What's your background? In what sense? Oh, I see. I get what you mean now. Yeah, so I guess I'm currently a student, finishing up my undergrad degree and starting my master's at the same time. Yeah, I've got pretty much a year on the dot now to go, and then I'm done with schooling. I've been doing academic research for compilers for a bit, but I've felt a little bit like my knowledge is historically a little bit weak, which is I guess part of why I'm working on this project at least. Okay, so something about spilling. Okay. Yeah, I guess that makes sense. What if I just did linear scan? I'm kind of lazy. Okay. Sorry, I'm just like reading through these slides. It's a little bit boring, but yeah, I've got like a little bit of a headache, low-key, so this is kind of rough. Yeah, something about graph coloring. Okay, interference graph. Okay. Something about graph coloring, yeah. Okay, so there's an edge between two variables that are like at the same variable point. That makes sense. Yep. So we just, yeah, that makes sense. This is pretty funny, actually. P equals MP is pretty funny. Okay. So K color graph, find a node with fewer than K edges. Delete the node and color what remains. We can find a color for this node if we add it back in. That makes sense. Okay. So fewer than K outgoing edges, we remove it. Okay, sure. I guess that makes sense. Okay. I guess that, okay, this all like makes sense at a glance. What is wrong with D? Oh, don't have enough registers. Okay, so we spill that, we color everything else. That makes sense. Huh? Okay, we're just gonna keep scrolling through this. Yeah, okay. Pathologically worst case assignments is really funny. Yeah, that, sure. How do I even want to pick an algorithm here from this point? I guess, okay, it might be time to go back to the book then. Interference graph. Yeah, so we kind of want to do something like that last little bit there that I kind of sped through. Yeah. Okay, let's look through this a little bit better. How do we even want to represent the interference graph? This seems awful, actually. Like, I mean, I guess this is like a pretty standard algorithm, but I don't know. I'm like functioning too slowly today to even figure out how I want to design the data structure. This does not seem fun. Okay, I guess we could start here. I guess we could at least make the file. That'd probably be a good start. So this would be in backend. I guess, I guess I don't know, what do we even do with this? Maybe instead of like putting it all in analysis, we could make like a regalloc thing. I'm not really sure what to do with it. That's not ideal, actually. I guess this is like technically kind of an analysis, so I will just throw it in here for now. We can refactor later as we see fit. Okay, so we could do like interference. We can do the C++ file. Yeah, let's start by looking at that. Yeah, I don't remember how to write headers ever, I feel like. Maybe I'm just like really tired, but okay. So we want interference graph. Or I guess we could just do interference. Am I spelling it correctly? Yeah, okay. Yeah, we can do that. I don't know what to do with that, but we can definitely do that. Is there like... I don't know. I don't know what I'm looking for here. Full blind. There we go. Okay. Okay, yeah. So we use live variable information. Okay. Yeah, I'm not reading this out loud because yeah. Let me make this at least a little bit larger. Linear scan. I'm kind of tempted to actually just implement linear scan because I haven't implemented it before. Okay. So we just have live intervals. Yeah, I'm quite tempted actually. That seems a little bit less awful to work with. We could also group by function as well. Is something else I'm thinking about. That might simplify things a little here and there. Okay. Yeah, I'm actually very tempted. The more I think about it, it just seems less awful. I guess linear scan register allocation. That's the paper. What was the spread post I read again? That doesn't really help a lot. Okay. So then, I guess I guess we could just keep reading through this. Interference graph. So, what do we do with this? How do we want to... How do we want to do something with this interference graph? The diagram below, there's no diagram below. Okay, I mean, I guess this doesn't need to be particularly complex. We could just make the data structure kind of slow and like not care. I probably should care, but yeah. Okay, let's look through here at least. See what we can reuse out of this. Okay, so interference graph, there's one node per machine register and one for each, I guess, symbolic register, which makes sense. Registers are homogeneous. They are not homogeneous. So we do need to include the registers in the interference graph. Yeah. Target machine has 2 more sets of registers. Okay, I don't care about that though. Sorry, I'm super tired. Our simplified description indicates that 2 nodes have an arc if they're ever simultaneously live. This can result in many more arcs than are needed. Interesting. Yeah, I guess that would be something I want to think about, because I have done just like the very basic version of regalok with an interference graph before. Okay, general enough to represent several sorts of interferences. Okay. Yeah, this is the part I'm curious about. How should I represent it? Space efficiency and time and access time are big concerns. Okay. This does not bring me joy. Jobless, yeah, that's kind of life. Really wish I could have a job and go to school at the same time, but I guess that's not something they will let me do. Adjacency matrix and adjacency lists. I guess that makes sense. Okay. Okay, that's not really helpful actually. Oh, actually this pseudocode is useful, at least in a way. Oh yeah, and then we care about coalescing as well. That's something I've never done before, so I think that'll be fun. I think that's almost mandatory here, in a sense, as well. Okay. Oh, this is not readable. Okay. Okay. And we're given this graph? Or where is the graph that we're looking at as a reference again? I guess that doesn't really help me because I'm not really going to be following it that closely, but 16.2. Here it is. Okay, so it's just a big adjacency matrix, which, sure, makes sense. I don't think there's a better way to do this, to be honest. Let's scroll back down to where we were. I do not remember where I was. It's presumably above here. Okay, can I like up arrow? Yeah, okay. Here we are. Let's do that. Or no, let's keep that on. Okay. Okay, this will be chunky, I think. Only real gripe with VS 2026 is the file viewer is awkward. Oh, I guess that makes sense. Yeah. I guess that's fair. I don't know. I haven't used it, so I can't really say anything. Lower triangle. I see. That would work. I might just do it like that. Yeah. Okay. Okay. I guess I could make like an adjacency matrix builder, but that seems annoying to write. Adjacency list, color, this does not help me, I think. Oh, we do need to figure out spill costs at some point, I think. Okay. How many nodes are adjacent and which ones they are? Adjacency list, okay. 16, 13. Okay, that makes sense. Yeah, I don't know. Is it one or the other that I should use? Okay, so there's pseudocode to generate that. Most useful during coalescing. The lists are most useful during coloring. I see. I guess that makes sense. I could probably do it like that. That seems interesting. Okay. So I guess I could probably make two different data structures then. I could make adjacency, or like, we could do like, what do we call it? So we have like, we could call it interference matrix, and we could call the other one interference lists, I guess. Like, they're both graphs, but I guess we could put them both here and it wouldn't really hurt anyway. So I guess that makes sense. Dual loading seems a bit much. I mean, I guess, yeah. The way I'm understanding what it's doing is it's just using the adjacency matrix up until we're done like until we're done coalescing registers, and then once that's done, we just use the use adjacency list version. How useful is the list though, or the list version? I guess not really. We could just store this info elsewhere and it wouldn't really matter. Yeah, I guess this isn't really useful. Like, I'm gonna make a billion maps anyway, like I always do for some reason. Okay, I think we will stick to the adjacency matrix at least. I feel like that's a good bare minimum. How the hell do I implement this? This seems annoying. I would rather avoid like nested map, but I feel like that always happens. C++, let's see what Geeks for Geeks says. I know I shouldn't look at their stuff, but I'm curious. Matrices use a lot in compilers. I don't know actually. My hunch is no at a glance because I can't really think of an instance immediately, or at least like an area where it's used a lot. Okay, so we're doing that. This does not help me. I guess we could just do this the lazy way. Actually, let's ask ChatGPT one question. For pointer types in C++, is it better to set types to indices or use nested word map? Yeah, okay, I guess that makes sense. That's fair enough. Yeah, okay, I guess that makes sense. Okay. Let's figure out how to do this now, I guess. You can represent the CFG as a matrix of the yeah, that's fair, yeah. I guess I don't think of that as like a matrix. I just think of it as a graph, which I guess is like a really stupid distinction, but it feels at least like meaningfully distinct, at least just because of how much it's abstracted away. Okay, how the hell do we do this? Do we know how big this is? I don't think we do. Okay, well, I guess 2D vector? Okay. ChatGPT said it. This ChatGPT is obviously the truth. I should 100% listen. I don't think there's another way to... I don't think there's a better alternative than vector. Vector of bitset? Tombstones? Yo, what? Okay, that's pretty funny. Yeah, okay. We will give this a try. Let's do that. Okay, so we have vector of pool, or vector hosted vector of pool. We can do JSON tricks, I guess. Huh? Oh, I need to, do I need to include vector? Or, I need to include something else at least. Let's figure out what else we need first. Unordered map from what type to, I guess, usize? Something to usize. This is, oh, duh, we want whatever the, are we using like literal register type for our like liveness? Yeah, we're using a register star. Yeah, it's gonna do that. I guess we could transitively import that through analysis. Let's import liveness. So this is reg to index. What is, oh, it's size T. Why am I using usize like it's Rust? It's just me when I asked ChatGPT for code architecture and structure planning. I generally debate myself ChatGPT is correct when I'm setting myself up for a bad code base. Yeah, I mean, that seems pretty reasonable. Like, that's kind of just like the ChatGPT experience, it feels like. Okay, what do we do with this? I guess we could just make a constructor and then like, that just takes interference? I don't know. Yeah, we could try that out maybe. Or no, it takes liveness rather, right? We have get in and we have get out, so that would probably help us. Okay. I guess that's kind of a good start here. I guess we should just do like just the constructor that takes liveness, right? Yeah, let's do that. Yeah, we'll do that for now, and we'll figure out what to do with that later. I guess we could just look at this stuff in here. This 12, yeah, okay. Oh, we should probably add, is there a place that we can like store the, like, I guess where do we figure out which registers, which physical registers exist again, because that's also pretty important. Maybe in here? Ah, yeah, that's where. Okay. So we can just do is there a way we can just do like all registers alternatively? Let's see if I was smart enough to implement that ahead of time. Okay, well, apparently I was not, so unlucky, I guess. Okay. So, argsave registers. Oh, I see. So we want just like everything in caller saved and caller saved for that. Yeah, I'll figure out how to implement that later, I think. Okay, so we can initialize that. Okay. I'm not sure what's happening here. Okay, so num webs. Okay, so we just this sets everything to false. And then why do this? I don't get it. What the hell? Yeah, this is looking rough. At least I'm feeling not great about this. I guess we could build this every time as well, but that seems a little bit heavy, so I don't want to do that if at all possible. This is not helpful. Coalescing will be something enjoyable to work on here. Holy hell. Just out of curiosity, how do we do spill costs? Because I don't think I've like read into this very much. Okay, spilling is the effect of potentially splitting a web into 2 or more and reducing interferences. That's not helpful. Okay. Positions are made carefully, make the graph archivable and insert minimum stores and reloads. Splitting register contents memory after set and reloading them. When they're about to be needed is a graph coloring register. Allocator's primary tool for making interference graph archivalable. That makes sense. Okay. Each element has a spill cost. We figured that much out. Okay. This is how we compute it. Okay, how do I even begin to read this? So you have weights and then each def, each use, and each copy, I guess, have weights, which makes sense. So def cost, on the use side, why does copy decrease weight? What is copy weight? Okay. I don't know. That's probably a question for me to answer myself later when I'm a little bit less dead. Prune graph, okay. Okay, and then assigning registers is a lot less miserable, I think. It shouldn't be that hard. Symbolic registers. Sure. Man, maybe I should encode size info in like my registers now that I think about it. That'd be smart. That would save a lot of brain cells elsewhere. Maybe I should do that. What are you hoping to get out of this project aside from learning? I mean, it is mostly just the learning. But I'd like to have a compiler that compiles down to x86-64 without sacrificing too much performance relative to the big production compilers, at least. Okay. Well, the rest of this is more example work. Okay, I think it's probably reasonable to just like at least scaffold this out and then probably just push it and call it a day. I am really just too tired to make this all work, I think. Yeah, apologies if today's stream is a little bit of a letdown. I guess we can just finish this up and we will call it a day. Interference.h. Sort that. Yeah. Okay. We need to do a lot of stuff here. We want to generate interference graph from liveness provided. I guess we could add the other things. So we want like spill cost. Yeah, I guess that's it. That's all we need, right? I guess we could generate that on the fly. I guess once we need it, we can figure out where to put it. That'll be easier. Anyway. Start interference. Like a stub. It's probably a reasonable word here. Yeah, we'll just do that for now. I'm very tired, so I might just take a nap and then I might do some schoolwork. Yeah, apologies if today's stream is like a little bit short, but that is kind of just life. Thank you all for showing up today. Hopefully tomorrow's stream will be longer. I don't have classes tomorrow, so I will 100% be more awake, and I'll probably think this design decision stuff through a little bit more. Yeah, make sure to like and sub if you haven't. Join the Discord, it's in the description. Add me on GitHub and LinkedIn, and if you wish to, feel free to donate at my GitHub sponsors. Yeah, I'm gonna go knock out now. Clear out the L1 cache behind me. Take care, all. Take it easy. Have a wonderful rest of your day wherever you are.